Hey ladies and gentlemen, we're going to be doing lesson 36 on writing and solving proportions. And actually we're going to be talking about similar figures. A similar figures occurs when two figures have the same shape. The angles are congruent, which is geometric word for saying equal, and the sides are proportional. We write it in this way, try and say triangle ABC is similar to triangle DEF. Okay, so this means similar to. Okay, and then we use scale factor, and it's a ratio of a side length of a figure to the corresponding side length of another figure. And so we'll talk about that a little bit later. We use scale factor with similar figures. Okay, so triangle ABC is congruent to triangle LKM. Find angle K and angle C. Well, if we go back, the definition says that their angles are equal. Okay, so we look here. A is going to match up with L. Okay, so angle L is going to be 135, and then B goes with K, so this angle is 25, and then C goes with M, so then this angle here is 20. So angle K is 25 degrees, and angle C is 20 degrees. So didn't have to do really any calculations for that. All right, the figures are similar. Find the scale factor and then use the scale factor to find x. Okay, so we need to find two sides that are corresponding. So that means that they're the same side in each of the triangles. So for example, that would be here, 5 feet and 3 feet. So we're going to write our scale factor like this. So that's our scale factor. Okay, and then we're going to use it in a proportion to help us find x. So we're going to set 5 over 3. And then we're going to match these two sides up. Now the x came out of the same triangle as this 5, so x is going to go on the 5 on the top because it's from the same triangle. And then this 5. Okay, if you go ahead and you cross multiply and you divide, you are going to find x equals 25 over 3, or if we do that out, 25 divided by 3 gives us 8.33 repeating, which is 8 1/3. All right, the side of a building casts a shadow 21 meters long. A boy who is 5 meters tall casts a shadow 4 meters long. The triangles are similar. How tall is the building? Okay, so I'm just going to put this x over here. And now it's just like our last problem. We are going to set up. So we have an x and 21. We have that are the same triangles. So we put them in the same one is fine. And then the boy is 5 feet tall. And that's how tall the building is. So tall, and then this one is shadow, and that's 4. So we can go ahead and cross multiply here. So 21 times 5, we divide by 4, we get 26.25 meters. If you wanted to, you could have set up your proportion where you put x and 21 on the same, so this is from the building, and then you can put the boy, the height here, and 4 there, and you'll be still making 21 times 5 and dividing by 4. Same one. Okay, the scale drawing of a kitchen tabletop has dimensions of 5 inches by 2.5 inches. So 5 by 2.5. Okay, if the scale factor of the drawing is to the actual table is 1 inch to 18 inches, what are the dimensions of the actual table? Okay, so 1 inch to 18 inches, that means that 1 inch on my drawing is worth 18 inches in real life. So all I have to do is take 5 times 18 and 2.5 times 18. Okay, so if we take 5 times 18, we get this to be 90. So we can say 90 inches by, and then we're going to take our 2.5 and times it by 18. And we get, for that one, 45. So by 45 inches. Let's see here. Do we want that in feet or leave in inches? Inches it is. Okay, so we just multiply those. And I think we've worked with a few problems like that already. All right, small toy cars are constructed using a scale factor of 1 inch to 64 inches. So you might hear this on small cars, like it's a 64th size. Okay, what's the ratio of the areas of the toy car to the actual car? Okay, so areas. So that's like inches squared. So we are just going to take our 1 to 64 and we are going to just square both of them. So 1 squared is 1 times 1, so we get 1. And 64 squared, or 64 times 64, is 4,900, or 4,096. And that's what we have. All right.